The science of time travel. The mystery of time. For centuries, humanity has gazed at the stars, not just in wonder, but in longing. We have wondered about the past, the fleeting present, and the future that seems just out of reach. Time, invisible, relentless, and yet deeply familiar, governs every heartbeat, every decision, every memory. But what if time is not just a river flowing in one direction? What if it could be bent, folded, or even traversed? The idea of time travel has captivated the human imagination for generations. From ancient myths to modern science fiction, it has been a recurring dream to revisit the past, to glimpse the future, to correct mistakes, to witness history firsthand. But beyond the stories lies a world of real science, a field that challenges everything we think we know about reality. Today, on Knowledge's Legacy, we explore the science of time travel, the extraordinary theories, the astonishing experiments, and the mind-bending possibilities that could one day make time travel more than just a dream. Before we begin, make sure to subscribe to Knowledge is Legacy. Every week, we unlock hidden truths about science, history, and the universe. Subscribe now to journey deeper into the mysteries that shape reality itself. What is time? Time is so familiar that we rarely question it. We measure it in seconds, minutes, and hours. We mark it with calendars. We schedule our lives around it. Yet, despite its omnipresence, time remains one of the most enigmatic concepts in existence. In physics, time is not merely a ticking clock. It is a dimension, much like the three dimensions of space. Together, they form the fabric of reality known as space-time. In this fabric, every event, every particle, every object is connected by the threads of time and space. Albert Einstein revolutionized our understanding of time with his theory of relativity. According to Einstein, time is not constant. It bends, stretches, and slows depending on speed and gravity. If you travel fast enough, close to the speed of light, time itself slows down. If you were to travel near a black hole, time would nearly stop for you compared to someone far away. This is not science fiction. Astronauts aboard the International Space Station experience a tiny version of this effect. They age just slightly slower than people on Earth because they are moving at high speed relative to us. In essence, they are traveling into the future by mere milliseconds, yet it is real. Time dilation, traveling into the future. Time dilation is the first tangible step toward time travel. Imagine two twins. One stays on Earth, living an ordinary life. The other boards a spacecraft, traveling close to the speed of light. When the traveler returns, decades may have passed on Earth, while the twin in the spaceship has barely aged. This is known as the twin paradox, a mind-bending demonstration of relativity. It is not a theory reserved for science fiction. It is a proven phenomenon rooted in the equations of physics. Time is relative, and under the right conditions, the future can be approached faster than the present. Scientists have even observed time dilation in particle accelerators, where particles moving near light speed experience slower decay than identical particles at rest. These experiments reveal that the universe already allows for glimpses into the future, at least for those who can move fast enough. Gravity and time. Einstein taught us that gravity and time are deeply intertwined. Massive objects like planets and stars do more than pull on other objects. They warp the fabric of space-time itself. This warping bends the path of light, creates tides in space, and slows time. Near a black hole, the warping is extreme. Time near the event horizon, the point of no return, slows so dramatically that 1 second near the black hole might equal years in a distant location. Christopher Nolan's movie Interstellar visualized this scientifically. An astronaut visiting a planet near a black hole experiences hours while decades pass on Earth. While dramatized for cinema, the underlying physics is sound. Gravity, it turns out, is a natural time machine, subtly altering the flow of reality itself. Wormholes, bridges through time. If bending time can take us forward, can we also leap sideways, or even backward? Wormholes, theoretical tunnels through space-time, offer that possibility. Imagine folding a piece of paper, poking a hole through it, and connecting two distant points. In theory, a wormhole could link not just locations in space, but moments in time. Physicists like Kip Thorne have studied wormholes extensively. While the math permits them, reality imposes immense challenges. To stabilize a wormhole, one would need exotic matter with negative energy density, a substance that may or may not exist. Even if we could create one, traversing it safely is another monumental challenge. But the tantalizing possibility remains: a cosmic shortcut through the continuum of time. Quantum physics and parallel timelines. Quantum mechanics adds another layer of complexity. Particles at the quantum level defy classical logic. They can exist in multiple states simultaneously, communicate instantaneously across distances, and exhibit behavior that challenges the concept of linear time. Some interpretations suggest that every choice we make spawns a parallel universe, a new branch of reality. In this view, time travel may not involve moving backward in a single timeline, but rather shifting between alternate realities. Imagine stepping into a version of Earth where history unfolded differently, a universe where small changes ripple through reality, creating a new future. Quantum mechanics hints that such parallel timelines could be more than imagination. The grandparents' paradox and time loops. One of the most famous questions in time travel is the grandfather paradox. What happens if you travel to the past and prevent your grandparents from meeting? Would you cease to exist? Physicists have proposed solutions. The Novikov self-consistency principle suggests that any actions taken in the past would necessarily fulfill history as it already exists. In other words, time protects itself. Paradoxes are impossible. Time loops, where cause and effect form closed cycles, are another theoretical possibility. They are strange, counterintuitive, and yet mathematically consistent in certain models of general relativity. Modern research and technological limits. Despite these fascinating theories, controlled time travel remains beyond our reach. The energy required to manipulate space-time is astronomical. Wormholes collapse before they can be stabilized. Even quantum phenomena are difficult to scale. Yet, scientists continue to explore the limits. Experiments at the Large Hadron Collider probe the fabric of reality. Theoretical studies of cosmic strings, negative energy, and optical time crystals push our understanding further. Even if full-scale time machines remain science fiction, the pursuit itself expands human knowledge and may one day bring the impossible closer to reality. Philosophical implications of time travel. Beyond physics, time travel raises profound questions. If the past could be altered, what would define free will? Does destiny exist, or is everything a branching set of probabilities? Could déjà vu be a glimpse into alternate timelines? Time travel challenges not just science, but our very understanding of existence. It forces us to confront the fragile nature of reality and the limits of human perception. Perception as time travel. Perhaps the most accessible form of time travel is perception. Memory allows us to relive the past. Imagination lets us glimpse the future. Learning and reflection enable us to navigate time mentally, even if our bodies remain bound to the present. In a sense, understanding time, bending our perception, and mastering our experience is the first step toward true temporal exploration. The legacy of time. Time travel may remain a dream, a distant frontier of human ingenuity. But even in theory, it inspires curiosity, exploration, and the relentless pursuit of knowledge. The journey through space-time is a mirror of our own human journey, seeking understanding, mastering limits, and reaching beyond what seems possible. And perhaps that is the true power of time travel. It reminds us that every second counts, every choice matters, and every moment is a bridge between the past and the future. Subscribe to Knowledge is Legacy to continue exploring the mysteries of the universe, the secrets of science, and the astonishing possibilities that lie just beyond the edge of our perception.